Hey guys, welcome to Safi Mixed. In this video, I want to use the skills we learned in our previous videos to solve this exercise as a practice to those experts, those rules, those skills. And we have given two space vectors A and B in terms of two sets of triples, and we have asked that we should find a third vector C through this one relation. So obviously for this first I need to find this part of the relation, that is twice of vector A, and this means I should write it like this. And now this representation means I should multiply this 2 with every single number inside these edge brackets, these wedge brackets, and that I can do by 2 times 2 is 4, 2 times minus 1 is minus 2, and 2 times 3 is 6. So this triple now represents a vector twice of the magnitude of vector A. And now if I put the value of this in this given relation, I can write C in the form of this 4 minus 2 and 6, and then plus 2 1 and 3. So now this representation means that we should add the corresponding numbers in the two triples, and that means I should add this 4 to this 2. So I would write 4 plus 2, and this minus 2 to this 1. So I'll write minus 2 plus 1, and this 6 to this 3, and I write 6 plus 3. That means the resultant of this is 6 minus 1 and 9. So this is the resultant vector given by this triple of numbers. We can obtain the same through the other relation we derived for addition of vectors. For example, we can express vector A in terms of unit vectors like this. Vector A equals 2 times unit vector I minus j plus 3 times unit vector k, and similarly I can write vector B in the form of 2 times unit vector I plus unit vector j plus 3 times unit vector k. So now I want to find this thing first, that is I need to find a vector which is equal to twice the magnitude of A, and that I can write 2 times this vectors 2 unit vector I minus j plus 3 unit vector k, and obviously this multiplies with each single term inside these brackets. So I can write this as 2 2s are 4i minus 2j plus 6k. Now we have this vector in terms of unit vectors, we have this vector in terms of the unit vectors, so I can find the x component, the y component, and the z component of this vector. I can either do separately or I can put these values simultaneously. So let me put them simultaneously. I can write this as this thing for 2a, 4i minus 2j plus 6k, and then plus the value of b, which is 2i plus j plus 3k. Now you see I can combine this term with this term to write it 4 plus 2, and taking the unit vector I common, I can combine this term with this term to write it minus 2 plus 1 into j. I combine this term with this term to write it 6 plus 3 into unit vector k. Now you see this is what we did in our previous video by adding vectors through components. This is the x component of A, this is the x component of B. So we have added the x components. This is the y component of A, this is the y component of B. We have added the two y components, and similarly this is the z component of A, this is the z component of B, and we have added the two z components. So as a result we get 6i minus minus 2 plus 1 is minus j plus 9k, which is the same as we obtained from the addition of two different triple numbers. So we can add it like this. We can follow the rule, the procedure for in the form of triple numbers or in the form of unit vectors. So these are the two different approaches. And thanks for watching.